Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. I don't know what I'm going to title this. It depends on what class you're in, and it depends on how I title it. But what I do know are our 3 goals for the day. Our first goal is going to be to create linear pairs and discover its property. Our second goal is going to be to define vertical angles and use a transitive proof to create a result. And our third and final goal is going to be to define complementary and supplementary angles. So let's go ahead and jump right into our first goal, and it's going to be to create linear pairs and discover its property. So in order to create linear pairs, we're going to start with a straight angle, ABC, which measures 180 degrees. So there's my straight angle, ABC. B is my vertex, right? We're going to add ray BD. So let me add that. Ray BD, translate that for you. Ray BD. So we start at point B and we go through point D. We're going to add ray B to straight angle ABC, and this is what we get. Okay, so we have our we now have 3 angles. We have this smaller angle, and our original straight angle. And so we're now going to write the angle addition postulate. And let me see if I have a marker that's going to write nicely, which I have a feeling I don't. There's a good one, I hope. Cross my fingers. So if we write the angle addition postulate, we're going to have the measure of angle ABD plus the measure of angle DBC. It's a terrible. There we go. I'll learn to write left-handed one day. And these 2 angles add up to our straight angle, which is a measure of angle ABC. So, by the way, this is the linear pair. Should have mentioned that, but that's our linear pair. We created our linear pair. And we also wrote our angle addition postulate for our linear pair. But I noticed something about my measure of angle ABC. It's a straight angle, which means it's 180 degrees. So my angle addition postulate is going to turn into the measure of angle ABD plus the measure of angle, try walking and chewing gum, the measure of angle DBC, and that's now equal to 180 degrees. This is the property that we wanted to discover about linear pairs. So this is the property we wanted. Linear pairs add to 180 degrees. This is the property. You can all better S. Okay, linear pairs add to 180 degrees. Now, sometimes we see linear pairs drawn like the following, where it's just a straight line, and off comes a ray, and there's just 2 numbers like that written in there. Okay, and from this, we assume the equation is property. Let me learn to write. I'm having a hard time today. We assume that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. Okay, so what we also have to know about linear pairs is we look for these in pictures. Look for them in pictures. Look for linear pairs in pictures. Right, look for them. Look for them. Where are you? All right, so I'm going to go ahead and check off our first goal here. All right, I created a linear pair and I discovered its property. They add to 180, and we want to look for these. These are going to be hidden in things, okay? All right, so I'm going to go ahead and erase everything, and I'll be back with the second goal. And so let me clean it all up, and I'll be back. I'm back. Let's go ahead and move into our second goal here, and that's going to be to define vertical angles and use the transitive proof to create a result. So right now, I'm going to define them, and then once we get through this, I'll come back and we'll do the little proof. Okay. So vertical angles are pairs of angles created by intersecting lines. Vertical angles share a vertex, and you can recognize pairs of vertical angles by extending the sides of one angle past the vertex. Sides of one angle. I'm leaving so many things out today. You know, this is what happens when you're trying to film like 5 or 6 lessons in a day. You make these little silly mistakes. All right. So I think we understand vertical angles better if we see some examples of what is a vertical angle and what isn't a vertical angle. So I have 3 examples up here, and I'm going to hopefully be able to show you using some color what I'm talking about. Here where they share a vertex, and you can recognize pairs of vertical angles by extending the sides of one angle past the vertex. Okay. So here I have a vertex, and I'm going to highlight my angle 1. Okay. And if I extend my my sides past the vertex, I've created angle 3. So we would say angle 1 and angle 3 are vertical angles. Now, if I was to do the same with angle 2 and extend the side past the vertex and extend the other side past the vertex, we could also say so are angles, let me learn my grammar, so are angles 2 and angle 4. So in this example, there's 2 pairs of vertical angles. Okay, let's go ahead and look at example 2. So what I'm going to do is I'm going to extend the sides of angle 5 and see what angle I create. So if I take my angle 5, which is highlighted in pink or fuchsia or salmon, whatever your computer screen or cell phone is set to, if I extend the sides, we see that it doesn't create a pair of angles. In fact, there's 2 angles on the other side of angle 5. So we would have to say that the angle 5 is not a vertical angle with anybody. However, if I look here at angle 6, if I extend the sides of angle 6, it makes angle 9. So angle 6 and angle 9 are vertical angles. Now, 7 and 8 can't be vertical angles because they're not created using intersected lines, right? So it's going to fail the definition. So there's actually only 1 pair of vertical angles in this second example, and that's angle 6 and angle 9. All right, on to example 3. Why don't you hit pause and figure out how many pairs of vertical angles there are in this one. All right, I'm back. All right, so let's start off with angle 10. So here's my angle 10. If I extend my sides of angle 10, I see that it creates angle 13. So angle 10 and angle 13 are vertical angles. Let's see here. Let's do another color here. Let's see if 11 is vertical to anyone. So here's angle 11. If I extend the sides past the vertex, I make angle 14. So Angle 11 and angle 14 are vertical angles. And finally, let's look at the last angles here. Finally, 12, if I, well, that's not a very good color to use, eraser. Let's try green. Okay. So here's my angle 12. If I extend the sides past the vertex, I make angle 15. So angle 12 and 15 are also vertical angles. All right. So what I'd like to do now is set up the next part of the second goal and create a little transitive proof that combines the first and second idea. And we would like to argue a property or a result using the transitive property. Remember, we're going to be making arguments using the transitive property, and so I think that it's good to see how proofs are done in this fashion. So let me go ahead and erase everything, and I'll be back. I'm back, so let's go ahead and continue with the second goal here. And so remember, our second goal is we want to use a transitive proof to create a result. So here's our proof setup. I'm going to tell you that angle 1 and angle 3 are vertical angles. Here's where we're going to make our argument. Remember what the first statement and reason always is. Here's what we're trying to prove. We're trying to prove that the measure of angle 1 equals the measure of angle 3. Here's a picture that represents what we're going to be arguing about. And I just want to remind you that this is a transitive proof, and we use the idea that if A equals C and B equals C, then A must be equal to B. If two things are equal to a third thing, then those two things are equal. And also, linear pairs is a part of this, this argument. So here's a big clue. Let's see if you can figure out what you can say about angle 1 and what you can say about angle 2. Because remember, I'm sorry, not angle 2, angle 3. Remember, we want to get these guys together, so there has to be something that you can say about each of these angles independently, and then you can go forward and make your argument. Now, why don't you hit pause and see if you can figure out something that you can say about angle 1 based on the given or what you're trying to prove or the picture, and do the same for angle 3. Hit pause and try and do that. Now, if you couldn't figure out anything, here's a hint. Here's a hint. Okay, it's in the picture. You're going to get the idea in the picture. So hit pause again and see if you can figure it out. Hopefully you were able to figure it out. You won't know until we work it out. But I hope that you did give it a shot. So anyways, I'm back. And I apologize in advance. I'm not very artistic, and you're going to see why here in a second. So when I look at this picture, I actually see two pairs of linear pairs. I see this linear pair, and I see that linear pair, right? So I could have this linear pair, and I know that linear pairs add to 180. So I can say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees. They do that because those are linear pairs. And again, you can see my drawing. And if I cover it up this way, let's see if I can draw that. I'm going to make the excuse, I'm actually not left-handed, so. So here I have another pair of linear pairs, and again, I can say that the measure of angle 2 plus the measure of angle 3, that equals 180. Okay, 180 degrees. Well, guess what we've created when we recognize that we have linear pairs? If two things are equal to a third thing, then those two things must be equal. Alright, so now I'm going to work my way through the proof and hopefully you understand the argument. And again, when we're doing transitive proofs, say what you need to, figure out what you can say about who you're trying to bring together. Right? Because we ultimately bring these angles together. Alright? What can you say about who you're trying to bring together? I'm going to write that down. That's so important. What can be said or written I'm going to even cloud circle it. This is really important. I'm going to try not to sneeze. Alright. Okay, so we know our first statement and we know our first reason. So our first statement is angle 1 and angle 3 are vertical angles. And the reason that they're vertical angles, or we can say this, is that's given to us. Now, I can also say that angle 1 and angle 2 are linear pairs, as well as angle 2 and angle 3. And the reason why I can say this statement and I can justify it is it's in the picture. Now, the next thing I'm going to say is what linear pairs do. So this is a property of linear pairs. They add to 180. And by saying what each angle does, angle 1 and angle 3, they're part of linear pairs. By saying that right now, you've created the opportunity to use a transitive property to get angle 1 and angle 3 into the same equation. So that's going to be step 4 that I need more room for. So I can say the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3, or equals, the measure of angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. And I can say that this is true because of the transitive property. Okay, we got one more step and we get to our result that we want. And you know who's keeping angle 1 and angle 3 from being in the equation together by themselves? The measure of angle 2. Measure of angle 2 is a number. So guess what I can do? I can subtract away a number from both sides. And in fact, they cancel out and I get the measure of angle 1 equals the measure of angle 3. And I can do that because I subtracted from both sides. Subtracted measure of angle 2. Right, so I got to my result because I said what I could about 1 and 3. And when I said what I could about 1 and 3, I created the transitive property, got rid of who I didn't want, and I got my desired result. So not only did we use the transitive property, but we got a result. And let me clarify what the result is. This whole proof shows us something. Vertical angles are equal. So let me erase this and make sure that we understand this. This proof shows us vertical angles are equal. We're going to be doing transitive proofs. That's it for a while. What can you say about who you want to get together? Okay? We proved vertical angles are equal. What we started with, what we ended with. All right, so we got one more goal to finish this lesson. So let me clean this up, set up our last goal, and I'll be back. I'm back for the last time, I promise. Let's talk about our third goal and finish our third goal. Define complementary and supplementary angles. Complementary angles don't say, "My, you look nice. You're so cute." No, they don't say that. They actually mean something. Complementary angles are two angles that add to 90 degrees. Supplementary angles are two angles that add to 180 degrees. Whose are supplementary angles? Well, an example would be linear pairs are supplementary. Linear pairs are supplementary angles, right? Because they add to 180. So these are clues. So again, in math, we talk to you in code. If I tell you that angle A and B are complementary angles, you know what? If I tell you that angle C and angle D are supplementary angles, you know what? For the first part, you know the measure of angle A plus the measure of angle B is equal to 90 degrees. And for the second part, you know that the measure of angle C plus the measure of angle D equals 180 degrees. Angle A and B are complements. And angles C and D are supplements. All right, so I'm going to go ahead and end it here. Again, I hope everybody is doing all right out there. Actually, let me summarize the lesson. I think that's more important. And then I'll say my goodbye. So remember, we created linear pairs and we discovered the property. We defined vertical angles and we used a transitive proof. I have to sneeze so bad. Oh, it tickles. And we made a transitive proof to create a result. So remember, when you're trying to bring things together, you want to say what you can about them. So we recognize that angle 1 was a linear pair with angle 2, and angle 3 was a linear pair with angle 2. And we use the fact that linear pairs add to 180 to create the transitive property. So this is how we're going to be making arguments moving forward. We're only going to be doing transitive arguments for the time being until I'm confident that you understand how to make an argument. And then we're going to see variations of this, all right? So again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.